So up here, since we didn't have that negative, it wasn't really a g prime of x yet. So we had to add that negative there to make it g prime of x over g of x. Right. Okay, so cotangent, I believe is negative natural log of sine, but I have to make sure. Like I said, whenever I'm not positive, I just go ahead and work it out. So if we go to integral of cotangent with respect to x, got my dx, our x. Okay, remember cotangent is just cosine of x over sine of x. Oh, sorry about that. Okay, so that means we have the integral of cosine of x over sine of x with respect to x. So just like we did with tangent, if we make our g of x equals sine of x, then that means g prime of x will equal cosine of x. Okay, so this would actually give us the integral of cosine of x, which is our g prime of x, over sine of x, which is our g of x, with respect to x, which is the natural log of g of x plus c, which is the natural log of cosine of x plus c. Oh, sine, thank you. Sometimes even if you forget one, you can kind of work it out if you know all the rules and remember your derivatives.
Would it be following the same format as cosecant, where it's negative log, or it is supposed to be a positive log?
Yep, it's supposed to be positive. Okay. Because our g prime of x is positive, so we don't have to add any negative numbers anywhere. Okay, so the integral of cosine of x is equal to the positive natural log of sine of x. Yep. All right, and I think I got all of them. I don't think I missed any. Okay, so the last few we have to do are our inverse integrals. So if you remember, the derivative of arc sine of x is equal to 1 over square root of 1 minus x squared. Kind of separate that, because if we integrate both sides, we end up with the integral of 1 over the square root of 1 minus x squared with respect to x is equal to the arc sine of x plus c. And remember, this would have been g of x, then this would have been g of x squared, and this would have been g prime of x. Just so happens if this is x, then x prime is 1. So actually, let me go ahead and write it out. Remember, derivative with respect to x of arc sine of g of x is equal to g prime of x over the square root of 1 minus g of x squared. So bring that over. Okay, so that means we have the integral of g prime of x over the square root of 1 minus g of x squared with respect to x. That's going to equal arc sine of, actually, let me make sure. Actually, I'm going to alter this just a little bit, because sometimes this isn't always 1. Okay, so let's say it's some number, bless you, a squared. Okay, and if that's a squared, then what you'd have to do is divide both sides here by a squared. So that would give you square root of 1 minus g of x squared over a squared. So that means that would be arc sine of g of x over a plus c. And actually, you really don't have to do the integral for arc cosine, because remember, the only difference between arc sine and arc cosine is negative. So instead of having a separate one for arc cosine, you can just make it negative arc sine. This way is one less formula to remember. All right, so we have missing arc tangent. The derivative of arc tangent of x, if you remember, is g prime of x over 1 plus g of x squared We're going to integrate both sides. You have the integral of g prime of x over 1 plus g of x squared with respect to x is equal to 1 over a arctangent of x. Or g of x over a, I forgot. That's right, for that one I put the a squared. I'll write it over again with just 1. But this is assuming it's just 1, so if it's just 1, I'll leave it like that. But I put it there just in case you run across one with something other than 1. So g of x over a plus c. Okay. So if you had just 1, I'll go ahead and rewrite it with just 1. Oh, that should have been g of x. So arctangent of x, remember that's just 1 over 1 plus x squared. So that means the integral of 1 over 1 plus x squared with respect to x is just your arctangent of x plus c. In this case, that's because 1 squared is just 1, and that's 1 over 1. So you don't have anything else there. And again, you don't have to do cotangent because cotangent is just the negative of arctangent. So if you have the negative of this, you just make it negative arctangent. All right, and last one, that is secant. I'm going to derivative of arc secant of just x. Remember that's 1 over a, which is 1 over 1, that's the next one. About to write arc secant over again for some odd reason. Okay, so that's 1 over absolute value of x, I had to remember that one, times the square root of 1 minus, let me make sure, x squared minus 1. There we go. Took me a minute to remember that. I don't know why I didn't write it down. Okay, so that means we integrate both sides. You have the integral of of 1 over the absolute value of x, square root of x squared minus 1 dx is equal to arc secant of x plus c. Or if you have the derivative, say you have a function in there other than x, it's some g of x, arc secant of g of x, that's going to equal g prime of x over the absolute value of g of x times the square root of g of x squared minus 1. G of x squared minus 1. So that means the integral of g prime of x over the absolute value of g of x times the square root of g of x squared minus 1 minus a. That's right. Keep forgetting. Yep, because that's just, the a there is just equal to 1. So, yep, this would be minus a squared. With respect to x is going to equal 1 over a arc secant of g of x over a plus c. Okay, so that's all of them. How many sheets did we go through writing all those? Actually went through 3 sheets.
This isn't going into like how you do the integrals of like power rule, chain rule, and all that, is it? This is just like the basic.
Well, we haven't gone to the chain rule for integrals yet. But this one's just, that would be u substitution. And that, I don't think you covered that here or Calc 2. I think you covered here. I'd have to double check.
For what, u substitution?
Yeah, u substitution for integrals.
I mean, either way, it's just getting, we kind of did like u substitution like all throughout, it's just like we replaced it with different terms.
Yeah, well, for derivatives we've done it, but I'm trying to think if we do it for integrals here. And I think we do it in this class. I'd have to double check.
It just breaks things down and makes it easier.
Yeah.
Okay.
All right, let's do right now. Oh, I'll leave that up there for a few more seconds.
Now, we don't have to go over cosecant, cotangent, or cosine because we can just assume it's the same thing except negative.
Yep, just negative. So if you had -1 here, that would be arc cosine.
Okay.
So instead of arc cosine, just make it negative arc sine.
Oh, I see.
Yeah. So it kind of cuts away having to remember 3 extra formulas. Okay. So now we'll do a couple of examples. Okay, so let's say you wanted to integrate. Oh, sure. Mhm. Let's say, what was it? 1 over x to the third with respect to x. All right. So with this one, you just rewrite it as the integral of x to the -3 with respect to x. Okay. So remember that the integral of x to the n with respect to x is equal to x to the n plus 1 over n plus 1 plus c. So this would just be rewritten as x to the -3 plus 1 over -3 plus 1 plus c, which gives us x to the negative 2 over negative 2 plus c.
So what is C?
Just any random constant.
Because there's no way of knowing what C actually was, correct?
Well, you can, and we'll do that for initial value problems, where you can actually solve for c, but they have to give you a point on the graph.
Okay. So you have to give it a
Yep, so it's under certain conditions that you can solve for c. Okay, so if we factor out that negative 1/2, that would be negative 1/2, and x to the negative 2 is just 1 over x squared plus c. You can always double check, because if you differentiate that, you should end up with 1 over x to the third.
Professor, when's your next exam? Is it next
It's
semester?
supposed to be next Thursday, but I'm thinking of pushing it until the following Tuesday to give you a little extra study time.
Is this all the honors that I take it?
Yes.
Okay.
That's why I was like, give you a little extra time. 'Cause I'm like, just that 1 week, that's, yeah.
I thought it was next class. I was just like, well, it's gonna be-
Nope, it was actually supposed to be next Thursday.
Okay.
So I'll just swing it to the following Tuesday, so you'll have that extra weekend to go over all this.
Sounds good.
All right, so let's say, for example, you want to integrate x to the 1/2 with respect to x. Okay, so it's the exact same thing. X to the 1/2 with respect to x is x to the 1/2 plus 1 over 1/2 plus 1. Oh, plus c. Which is equal to 1/2 plus 1 is x to the 3 over 2 power divided by 3 over 2 plus c, which is equal to 2/3 x to the 3 over 2 power plus c. Okay, so let's say if we wanted to solve the integral of 2 sine of t with respect to t. Okay, sometimes they'll throw a t in there, sometimes they'll throw an x, sometimes they'll throw an r. Same thing. As long as the variable here matches with the variable you're integrating with respect to, it's the exact same steps. Okay, so remember that the integral of sine of t, with respect to t, is equal to negative cosine of t plus c. Okay, so that means if we factor out that 2, we have 2 times the integral of sine of t with respect to t is just going to equal 2 times negative cosine of t. Forgot my negative. I'll just put the negative up front. Plus c. Okay, so normally this would be 2 times this entire integral, which means you'd end up with 2, or negative 2. Oh, yep, just 2. 2 times the integral of this, so it would be 2 times c, which is still just a constant, so you just keep it as a constant c. All right. So any questions on any of those?
So you do bring out the negative to the front. Correct.
Yep. So instead of 2 times negative cosine of t, just brought it out.
And then you said it normally does multiply the 2 by the constant,
Mhm.
but because it's just constant, a number.
Oh yeah, because this is just 2 times this integral,
Yeah,
so that would be 2 times negative cosine of t plus c, which would give us -2 cosine of t plus 2 times a constant, which is still just a constant. So you just leave it as a constant. Mhm.
Can you, I might just be assuming, can the second derivative of the sine be the integral of, I might be saying it wrong, so
Mhm.
the derivative of sine is cosine, right?
Yes.
Now, what if I took the second derivative of sine, which would be negative sine?
Second derivative sine, yep, will be negative sine.
Can I not? All right, no, never mind, I figured it out. Never mind.
Being of the second integral,
Maybe that's what I'm thinking of.
you'll do second integrals right there. Well, third integrals right there. So.
Isn't there like a, I think one of the tutors was talking about it, there's like a derivative like circle that you can do, kind of? That you can make where it's like, you can put it on a chart of like sine, cosine, like, and then cosine to sine or something like, I don't know.
Could be. There are probably a lot of
It's
tricks
like a
that,
trick to
yeah,
remember.
probably a lot of tricks I haven't seen yet.
So, I thought the derivative of sine is cosine, not negative cosine.
Yep, the derivative is. Because if you think this way, the derivative of cosine equals negative sine. Oh, you figured it out.
Yeah, because you're going backwards.
Yep, you're going, yep, backwards.
So you're so used to going forward, you're going backwards. So like, for example,
Mhm.
if that was 2 cosine t,
Mhm.
then you would have sine.
Yep, it would just be 2 sine.
Yeah, 2 sine t plus c.
Yeah. All right, so let's say if we wanted to integrate x plus 2 with respect to x. Oh, let's bring that down some. Okay, so here you just distribute the integral. So that's the integral of x with respect to x plus the integral of 2 with respect to x. But really at 2, you can just bring it out to the front. Okay. So here, you have the integral of x to the n dx is x to the n plus 1 over n plus 1. And you have the integral of any constant. Actually, you can use the same one for both, and I'll show you why. So let's say instead of the integral of 2, I'll just rewrite it. We make that the integral of x to the first power dx plus 2 times the integral, make that x to the 0, since that's just 1. So if you have 2 times x, well, 2 times 1, you just factor out the 2. Now, you don't have to do this every time. This is to kind of show how it works. So this is x to the 1 plus 1 over 1 plus 1 plus 2. This will be x to the 0 plus 1 over 0 plus 1 plus c. So that would give you x squared over 2, which is 1/2 x squared, plus x to the first power over 1, which is just 2x. So this is just to show, plus c. So this is just to show that the integral with respect to x will just end up being x. That's how when we factor out that 2, you have the integral with respect to x. That's how it came up to be that. But for the most part, you just use that.
So what's the final answer?
Oh, this is the final answer. It's kind of the same way you know how the derivative of 2x would just equal 2. You don't have to do the 1 minus 1 times 1 and all that. You just pretty much know after you do it for a while. Same thing here.
I feel like doing it in your head is a little easier than actually writing it out.
Oh yeah, this right here is completely unnecessary.
Yeah, because I just like, with the equation, I kind of just like thought of it
Mhm.
as in a reverse way. and
Yeah, that's it. All you got to do when you integrate, like I say, integrate and there's nothing there,
Yeah.
or you factored out the constant, it's just going to be x. You can think of it this way, where the integral and the derivative cancel each other out.
So you
You're
have to
left
show
with
the
x.
work like that to get the credit.
Oh no, if you did it this way and then you just ended up with 1/2 x squared and 2x, just from there to there, that'd be okay.
So technically the stuff of when you did 2 integral x 0 plus 1 and then on the
Mhm.
bottom divided by 0 plus 1, that's technically useless because x to 0 automatically equals 1 anyway, right?
Yep.
Okay.
That was just more of a step-by-step of how I got there.
Gotcha. Okay.
All right, so let's say if we get one a little trickier. Trying to think if I should start on a page. Yeah, I'll start on a new page. Anyone still writing this one? All right. Don't want this to run out of room. Let's say if we want to integrate -5 x to the third plus 4 times the 5th root of x divided by 4x with respect to x.
Is that x to the first?
Oh yeah, this is just x. I always close off my
Oh, you like
square
throw it
roots.
off.
All right, now with this one, you just kind of want to rewrite it a little bit. Oh, so that, might as well put that whole thing in parentheses. So you can really separate these two. So you can make that the integral of -5 x to the third over 4x plus 4 times the 5th root of x over 4x. Let me clean up that 5 a little bit. With respect to x. So you can simplify each one. Okay, here, an x can cancel out, and x can cancel out, and you can actually factor out that 5 over 4, or -5 over 4. Okay, so that will give you the integral of -5 over 4 times x squared plus the 4's here can cancel out. So you have the 5th root of x over x.
X squared is on the outside of that, right?
Yep, it's on the outside. So it's just like times x squared with respect to x. Okay, now this term, you can actually simplify that too. So remember, the 5th root of x is just x to the 1/5 power. So that gives you x to the 1/5 power divided by x, you might as well say, to the 1st power. So your rules for exponents when you're dividing is x to the 1/5 minus 1, which is x to the -4/5 power. Okay, so if we rewrote this, we have the integral of -5 over 4 times x squared plus x to the -4/5 power with respect to x. Okay, so we have both terms simplified, which means we can go ahead and kind of distribute our integral, which gives us the integral, we'll bring that -5 over 4 out, of x squared with respect to x